Okay, we're live. Hi guys. Last round of the finals. Thanks again for joining me. Let me just bring up the presentation that we shared on the day as well, and then we can just do a quick introduction. I'm supposed to share my slide like that. All right, so yeah, the finals of the Microsoft Excel World Championship South Africa was on on the end of August, 30th of August. We crowned the new champion, and yeah, it was amazing. And this was the last case of the finals, so we'll talk about the case now. I just wanted to quickly just say thanks again to our sponsors. Main sponsor being Bidvest Advisory Services, or Alice, and then we also had CPD Campus, App Venture, Excel Academy, and MyBI. So thanks to the sponsors. We're going to talk about the case. Jason, you want to maybe talk us through the case, because Steyn says he's the strong silent type. So you want to maybe talk us through the case logic.
Yeah, no, sure. I think off the bat, a really unique case, a lot of fun, pretty brutal if you ask me. Um, on the day, on the day, we said to the participants that the cases were not necessarily in order of difficulty. Everyone participated in all three of the cases, and we aggregated the scores. And I think depending on your strengths, case one and case two could have gone better or worse for you, depending on how you do. Perspective, case three was the hardest on the day, and it was the final round, and was ended up being the the factor that determined the winner. And so I think it ended up in the right place. Um, but a pretty tough case, and I think to get your mind around. And funny enough, the concept is not complex, but it turned out that I think trying to model it was quite brutal. And I'll say off the bat, I said publicly on the day that I still hadn't solved level four. So I'm looking forward to Renier and Steyn taking us through level four later in the video, because I'll have very little to contribute there other than what did not work. But let's chat through the context. So is essentially you positioned as an employee of the South African National Space Agency, SANSA, and you've made contact with an alien race called the Blorkins. Super exciting. The really interesting part about the Blorkin race is that they count using a base 7 number system, because they've got 3 fingers on each hand and a tail. So they've got 7 digits to count with. And unlike the humans on Earth with a base 10 decimal system, they have a base 7 system. And then just to add a little bit of flavor to the mix, they don't count 1, 2, 3, 4, 5, 6, 7. They count 1, 2, 3, 6, 8, 9. And then 0 is the same base as we've got. And so we had to sort of deal with this. And then to sort of add another layer of complexity, they use the same digits for words, but then indicate whether something is a word or a number, depending on whether the little, I don't know what you call that, half moon is like smiling or frowning. I don't know how better to describe that, but if it's pointing up or pointing down, denotes whether it's a number or a word. And so you have to deal with, sort of, I suppose, fairly typical in these Excel cases, a bit of splitting out text, lookups, functions, dealing with the length of the characters, etc., to really unpack the case. And I guess as we go, you'll see the need to consider text length, etc., because when we start doing the mathematical operations in some of the levels, you'll see that we need to potentially flip the numbers around because negatives go the other way, etc. And so we got into a bit of mathematics as well, which made it a super interesting case, and once again very humbling, because you think adding two-digit numbers or subtracting a 2-digit number from a 3-digit number should be something you can do in grade 1. turns out that trying to model this in Excel with a base 7 number system that reverses the digits is not child's play. So Steyn, really, really great case, lots of fun. And I think maybe just as part of the intro, you mentioned to us on the day how you came up with the idea for the case. And I think worth sharing that on the recording here for the walkthrough, just for the sake of capturing it in history, because it's quite a nice background.
Yeah, and I saw in the WhatsApp group someone talking about that we've done binary cases, but we haven't done trinary cases yet. And then I decided instead of doing a trinary case, like why not go base 7? I do not want to go like base 8 or something, which was divided by 2 or so. So I wanted to make it interesting. So and then I decided on base 7.
Yeah, so we scaled up from binary and then skipped trinary and quadrinary or whatever it would be, straight up to a prime number, base 7, and then chucked the numbers around and swapped the numbers and added multiplication and division, and away we went. So yeah, no, really good fun.
And even changed order of operations as well. So
that's the part that threw me. So level 4, here we go.
Yeah, but yeah, I think I have to agree. Excellent case, Steyn, and I think a lot of our participants, I think all of our participants are mathematically brained, if I can say that. We mostly have engineers, accountants, and actuaries that participate. I think the actuaries enjoyed this the most. They also did the best. In this case, I believe. I think there was one chartered accountant that actually did really well, and that's Franco. But yeah, so I think everyone enjoyed it, and I think everyone was perplexed by it. And the other thing that I realized is after spending some time and wrapping your head around it, you start thinking of other ways, and you start thinking of easier ways to unpack it. I think you had tried it a second time, Steyn, and you said you could solve it in 11.5 minutes. I really want to see how Dim does it and how long it takes him. I think this might be a case where Dim doesn't get full marks in the time, but let's see. He might surprise me. And yeah, so just the other thing that I wanted to talk about is just for those of you that still can't wrap your heads around the base 7 versus base 10. So if we talk about if we talk about a normal decimal system, you typically have if you have a number, let's say your number is 1, 2, 4, 5, 8, right? Then it's 12,458. So in the position, so you basically have ones, you have tens, you have hundreds, and you have thousands, and then you have 10,000s, right? In this case. And essentially what you have is you have eight in the position of ones. Then you've got 5 or 50s in the 50 in the tens. You have 4 in the hundreds. You have 2 in the thousands, and you've got 1 in the 10,000s. And actually, to get back to that, you use a base of 10. So it's 10 to the power of, and it's or the number. So basically, it would be, and help me out here, guys, if I get this wrong, but it would be 8 times 10 to the power of
0.
To the power of, and in this case, it's 0. But your sequence would go, if I go and put a sequence down, it will be a sequence of 5 where I start with 0. Basically, if I take that and I do that, then that's basically, okay, not that one like that. So if I do that, that is what makes up the number, right? And if I sum up all of that, that makes up my base, my base 10. Essentially, with Blorkens, this is now working in sevens, but this concept still sticks. The fact that you could go and say, take the value of the number in the ones position, and then multiply that by 10. In this case, it would have been 7 to the power of 7 to the power of 0, 1, 2, 3, 4, right? And essentially that is the difference here. And then the other complexity comes in with the fact that you count 0, 1. I'll just put them in a list like this: 0, 1, 2, 3, 6, 8, 9. And that's the 7 numbers that makes up the base numbers. So multiple ways how you could have tackled this case. And I guess I'll get into level 1 now. Yeah, essentially this block of information is the same as we showed on the PowerPoint slide. And then the bonuses: bonus A relates to level 1, B to level 2, C is unrelated, and then D and E. And I tested this case on an older version. Before we had the little alien, we had a little alien worm. This was still the version that was sort of one of the first testing versions, but the essence is still exactly the same. Essentially, if we go into level 1, level 1 said very easy, but I think a lot of people already struggled here. But it was down to, could you wrap your head around it, right? So the first case, or the first level, is essentially asking us to translate positive Blocker numbers to human numbers. So essentially, take base 7, make it base 10, or yeah. So essentially, in Blocker, a 10, a 1, 0 is equal to 7 for humans, and Steyn gave it away there by saying 1 times 7 to the power of 1. Okay, while a 1 is worth 1, or 1 multiplied by 7 to the power of 0. Okay, and that comes back to what I just showed on the base 10. So in example 1, we've got a number of 90, and essentially that little half moon, as Jason called it, or smiley, is indicating that it's a number, and it's made up of 9 in the 10 position and 0 in the 1 position. And since 9 is the 6th number in Blocken, it would be equal to 6 multiplied by 7 plus the 0 multiplied by 1 in human, which is 42. Okay, so essentially what I did was I created a little lookup table manually. I literally wrote out the numbers that we just spoke about: 0, 1, 2, 3, 6, 8, 9. And I think I called this sevens. And I went and wrote 0, 1, 2, 3, 4, 5, 6. I could have done a sequence on it, but I called this tens. And throughout the cases, I used sevens and tens to do the conversion. I haven't looked at this case in a while, but I'm going to try and explain what I did. And eventually, when I got to level 4, I started building a lambda, and I essentially created one lambda that could do all the Blocken stuff as a conversion from Blocken to normal decimal or Arabic numbers. So, as Jason said, in the end, you had to be able to split out text. So that was one of the first skills that you needed. And essentially what I did was I initially just started by getting the first character isolated, and just use a left function for that. And then I did, and I said, I went and I tried to see, we're only working, I quickly went through the case and I saw that we're only working up until 3 digits, which was actually a nice gift from Steyn, because it could have been a lot worse. We could have been working with larger than 3 digits, which would have been getting into very difficult territory. But later on, there's actually a better way to handle this. But essentially, I said if the length is more than 3, then take the mid of that number for the length of that number, less 2, and for one character. So essentially, what I wanted to just extract is thousands, tens, and ones, and essentially. Basically just said, okay, if the length is more than 3, that's the number, otherwise it's 0. So essentially that's just allowing me to extract the value in the thousands position. And then did the same kind of logic for the tens position. Most of them had something in the tens position, so I didn't have to look at length in that case. Later on, I actually padded the number with a 0 at the end or in the front. But yeah, that's how I extracted it. So I used left or mid or right in this case. Right is just basically extracting the last number, and I didn't even need that optional number of characters because I'm just extracting one number. So, and in each of those, I used the little double negative or double dash to convert these to actual numbers, and not just have them return as text in Excel. And then to convert that to decimal thousands, I basically initially, before I wrapped my head around it and did the 7 to the power of, I said, well, for ones, I had to basically just do an X lookup between these sevens and tens for that value and multiply it by 1. Okay, and then for the second, for the tens, I had to multiply that by 7. And then so I had to multiply the actual number by 7, or it would have been 7 to the power of 1, which is still 7. And then for the other one, it would have been 49 multiplied by 49, or in this case, 7 to the power of 2. Yeah, 7 to the power of 2. And in the end, it's just basically summing up all those numbers, and that got me the actual numbers themselves. Can't remember what I did. Yeah. I think this was maybe for a bonus question or something, but that was how I initially did level 1. Okay, so maybe before I go to bonus question or bonus level 1, I know Steyn, you did it in a much more eloquent way, but Jason, did you do anything much different or very different?
Fairly similar layout to what you've got. I did split initially each of the characters into different columns, but then pulled them into a hundreds, a tens, and a units column, similar to you. I used a slightly different approach, but much the same logic. And then I did the 7 to the power of, which you've explained as a starting point. But other than that, the layout looks very similar, just the maths part. The formula build-up is slightly different, but much the same. Not much to add there.
Yeah. Okay, cool. Steyn, I know that you did it very similarly. You basically did the 7 to the power of 0 for ones, 7 to the power of 1 for tens, and 7 to the power of 2 for thousands, right?
Yes.
Okay. So it's not thousands, it's hundreds. I realize now. All right, but yeah, when you're under time pressure and you've got lots of things to test, that happens. What I wanted to okay, so before we get to that, let's talk about bonus A. So bonus A relates to level 1, and in that case, the question was, in level 1, which digit from 0 to 9 appears least often, taking into account both the questions and the answers, exclude the example. Okay, so what I did there was I quickly just put that into a separate sheet, and I basically went and I v-stacked the question and the answers, and then from that, so v-stack basically just stacks them vertically on top of one another, and then what I did was I text split the character out. So basically text split by a column delimiter of that little smiley half moon character, and then concatenated that back and converted into a number so that I was just left with numbers themselves. And then I split these numbers out with a mid sequence length logic. So basically saying, give me the mid of that cell. So mid basically just extracts text from the middle, and the logic is that it should extract it in a sequence of the length of that which would have been 2 in this case. So the sequence would return position 1, position 2, and how many characters, the number of characters that needs to be extracted from the mid is 1 character at a time. And that little trick just allows me to split out any of these into 3 different into the 3 different characters. And what I then did was I put that into a column. I used the toCol to put that into a column, again with ignore blanks and errors, so that it could ignore any places where there's not 3 digits. So it basically just gave me a singular list. And again, hashtag should have a lambda for that. I know that Dim has a lambda that I think it's just called most of or least of. But basically, all I did was I went and I created a sequence of 0 to 9 and did a count if that number occurs, if 0 occurs in there, how many times, and then realized that the number 7 only occurs 2 times across all of these numbers. And how I basically extracted that was with an XLOOKUP of looking for 0. And the type of lookup is basically the match mode is basically, if I do that, it's exact match or the next larger item. So it's going to look for anything higher than 0 or anything close to 0. And the closest to 0 would be 2, which would return for me, the number 7. And that's basically how I did bonus 1. Because I've done this 1,000 times, this is quite quick to do, but I know that a pre-built Lambda would be a lot faster. But yeah, that was pretty much bonus 1. I don't know if you guys had a different way of doing that.
Well, I would say you're making the start too complicated, because you don't need to keep the numbers separately. So just where you did the concatenate, just do concatenate on everything, all the numbers at the start, and then just split it out. So what I did is I just did the concatenate on both the questions and the answers together, and then I used the mid in a sequence to split it out.
So you basically skipped some of these steps. Yeah, that makes sense. Good point. I'm going to try and be better next time. Okay, so I guess what I wanted to just also chat about, Steyn, this is something that you also spoke about on the finals day. That was also an option for people to actually use, and I think this is a very nice way, especially if you build this into a Lambda. There's a very nice way, and I just wanted to outlay the logic of this. So just to explain, so in Blorken you basically start with 0, and it's 1, and it's 2, and then 3, and then 6, and then 8, and then 9, right? Which means the numbers that you don't use, the 3 numbers that you don't use to take it from 10 to 7 would be the number 4, the number 5, and the number 7. Okay, so what I wanted to just show was that if you had went and you said, give me a sequence of 9,999 numbers, you'd get the numbers from 1 to 9,999, and then you could write this into a quick Lambda yourself as well. But essentially the logic is just, if the number 4 exists in the number, or if the number 5 exists, or if the number 7 exists, it shouldn't be part of my Blorken numbers. So if you then use a filter, and you filter basically for everything that should be there, then you're left with all the Blorken numbers. So you basically get 0, 1, 2, 3, 6, 8, 9, and then 10, 11, 12, 13, 16, 18, 19, and then etc. Right? And then if you put a sequence of rows next to that, you basically could also solve bonus 3. But for everything, you could actually get to all of the numbers that makes up everything in Blorken. And that could have become your lookup table as well. And then you didn't have to deal with tens and hundreds and ones and stuff separately necessarily. So I just wanted to show that as well. Sorry, that was another Steyn idea that I just basically made it happen just before we started this recording tonight. But yeah, I guess I just wanted to show that to the participants, and a lot of you might go, "Oh, that's so simple," but that is also something you could have done.
Yeah, in my 11-minute attempt, what I did is, instead of using formulas to take out the ones with the 4, 5, and 7, I just put a filter in it, and then for those rows that contains those numbers, I just deleted those rows, and then that left me with the valid block and numbers, and then I just put a sequence next to it.
Yeah. So you just did a manual filter delete. That's also pretty easy. Yeah. Okay, so yeah, so I'm sure we'll see it in the Bo speed run, where he will solve it in 2 minutes and 31 seconds or something. But yeah, so the second level is quite a lot more difficult, but still considered easy based on this case. But essentially, it's translating negative Blocker numbers to human numbers. And now the intricacy comes in that a negative number is indicated by a number, or the smiley moon, which indicates the number, but then also that little triangle with a dot in it. I have no idea what it's called, but that triangle in a dot indicates that it's negative. So not like decimal numbers where you would have a negative or a minus sign. You basically have that little triangle. For humans, the smallest numbers, or the ones, remains on the right. In base 10, 1, 2, 3 is the same, or minus 1, 2, 3 and 123 both indicates 3 in the ones, and it's the rightmost number. But in this case, in Blorken, for negative numbers, the sequence reverses. So your ones, tens, and thousands reverses. So in other words, we know that this little 90 or 90 is equal to 42 as in example 1 in level 1, but in example 2, it's basically 09, which would be negative 42. So seems very difficult, but if you know how to change sequences, not very difficult. Or you didn't have to necessarily change sequences, you just had to deal with that character, and then reverse your logic. Instead of left, you would go right, etc. And you could have still done the mid, etc. So what I did was, to build for levels 3 onwards, I basically went and I just said, okay, so if the left of that character is that sign, it's a number, and if the second character essentially is that little triangle, it's negative. And then the numbers, what I then did was, just want to see what I did again, but basically I did a text split, and again a concatenation, but I padded it essentially with a 0, so that all my numbers are now actually 3 digits. Again, I just had to deal with 3 digits, but essentially I could pad them so that I could more easily extract my tens, my ones, and my hundreds. And essentially I used the same logic, but I just swapped it around. So instead of taking the left, I took the right for the hundreds. And then for the tens, I would have just had to deal with the mid, the actual number in the middle, because now that I've padded it, it's a lot more simple. It's the same logic. I don't have to test for length, and then ones would have just been the left in this case, and then the same conversion applies. So if your build of the level 1 logic was good, I think level 2 would have been an easy solve. Otherwise, level 2 would have been a start from scratch kind of solve. And I did exactly the same, multiplied by 1, 7, and 49 in this case to get to the numbers. And I think I just did I just tested for negative. If it's negative, I multiplied it by -1. Otherwise, I multiplied it by 1. So that was essentially the logic that I applied for level 2. Steyn, Jason, did you guys do anything fundamentally different?
No, not really.
No, quite similar. I just want to, Renier, your concatenate or putting a 0 on the end, on the face of it to me wasn't obvious why that works, but it's quite genius actually. Like put a 0 on the end because you've got a 3-digit number already, then taking the left of the 3 characters on the left ignores the 0 that you've added, so it's not turning it into a 4-digit number. And padding the 0 on the end, because we're reversing the numbers, is putting the 0 in the hundreds, and that to me was the part I was not clicking when you were talking through it. But that, like, it's crazy how simple that logic is, to just make it a 3-digit number that puts a 0 in the hundreds when you reverse it. That would never have occurred to me. It's like, it's genius.
Yeah, it's a trick. It's a trick that I learned quite some time ago when I was working in SQL with data sets, especially if you're working with things like funky employee numbers or something like that. If you have numbers of differing lengths, you could pad before or pad after.
Yeah.
So basically, if you had the number 1, the number 1, 2, and the number 1, 2, 3, and you wanted to work with 3 digits in all cases, you could just go and say, give me the right of essentially, you can pad it with as many zeros as you want,
Yeah.
and then basically concatenate that with the number, and then return just the number of characters that you want in the end, and that would bring back the same length of characters every time in a text. And there's a lot that you could do with that. So
that's such a great takeaway for me. Jeez, that's brilliant.
Cool. So, and then something that I also saw that I did was I extracted the characters and I kept them over here. I just want to see if I used them. I think I used them for the text split. So I guess just another takeaway for the text split is that your text split can handle an array of more than one character. I think we've said this multiple times, but that means that the text split concat is essentially removing both these characters for me in all cases. So I was building with positive and negative numbers in mind. And this was basically leading up to my lambda that I built for level 4, where I had to test for number, I had to test for negative, and I had to deal with both positive and negative numbers by padding them essentially, and then extracting the hundreds, the tens, and the ones, and doing the conversion. So I'll talk about that a bit later, but I think Steyn, it's now your turn. With level.
Did you do bonus 2?
Oh, let me do bonus 2. So bonus 2 is asking what's the lowest number in human numbers in level 2, excluding the example. Again, well, yeah, you could have just used min. And I basically just used the min of all of this. I think I think the catch is under time pressure. You might say the answer is -8, but it's actually -63, which would be the lowest number. So that's just what I did. I just took the min of that, which was pretty much a giveaway 40 points if you had solved level 2. Steyn, you want to take us through level 3 onwards?
Yes.
Just a note while Steyn's pulling up the case there. Both bonus A and bonus B, interestingly, required you to have solved level 1 and level 2. It wasn't just using the logic, which is an interesting take on some of the bonuses. So it actually forced you to actually have solved it. You had to get the right answers, or at least like get lucky at being pretty close. But yeah, which was an interesting sort of take on the bonuses.
Yeah. So for my first attempt, I also did that lambda where I split it almost like Renier did. But for my second attempt, what I did is I also just created a sequence, and then you can just do a search. So search for the invalid numbers, and if it's not found, then make it a 0, which means if it's a 0, 0, 0, then it means none of these numbers have been found, which means it's a valid number, and then I just change it to true with not. So if there's any numbers that's found here, then it would be a 1 or more, and then the not would change it to a 0. So then I have the valid blocker numbers or not. And then what I can do is on the human numbers, I just put, so if it's a valid number, take the maximum number of the ones that I had before that and just add 1. And then for the blocker and positive numbers, it was just adding that symbol at the front. For the and the words later, I could add the different symbol at the front. And for the negative numbers, then it was just a matter of reversing the number I have here. And once I had this, then I could just, this column and yet this column, I have the positive numbers. And then for the negative numbers, I just need to bring in this column and with this one, which was just the human times negative. So I just put that here. And then the words I could put here below. And then at the top, I did my multiplication table. And then what this allowed me to do is basically I just do a text split based on a space and then just do a VLOOKUP to convert it to human numbers. And that gave me, it does the conversion, and then here I just added it together. And then from this formula to get it back to human numbers, I just copied it, and then I just pasted it as value. And then what you can do is you can use just text to column, and then it solves it for you. And then it turns the text formula and forces it to calculate for you.
Okay, wait. So, okay, wait. Let's backtrack. Okay, so just scroll up to level 3's logic. Let's just tell the people who haven't seen it yet. So in level 3, basically we've got math operations. So essentially you have the human operations, which is multiplication, subtraction, addition, and division. And in Blorken, there's a different symbol for each of those. And essentially now you're getting, in the example, you're getting the Blorken number 32, and then the subtraction character in that case, and then you have the Blorken number 22, and those two basically equates to, what is it, 23 less 16, which is 7, which is the answer. So that's basically the preamble to this. And, you know, Steyn, I think you've shown a lot of things. Maybe just go to your list again, or your alternative, or what did you use there? The list. Okay. So something that I just wanted to highlight was how you did the negative, the sequence, the reversal of the sequence. Maybe just explain that.
The negative, it's basically just taking this value here and then just reversing it with a sequence. So in the sequence I said, take the length of it, start with the last number, and then do a negative step, which gives me the reversed value.
Now, so again, the mid extracts a specific number or character from it, and then your sequence is basically just telling it which numbers to extract. So your sequence starts with starts with the highest number, which is 2 in this case, and then goes -1. It would actually go 2, 1. So it would extract the second character first and the first character second, and then you concatenate those two.
Yeah, and I add the negative Blorken symbol at the start.
And that's very clever. And then the second thing I just wanted to unpack is that it's text to columns that you did, which is again very cool. A trick that you learn when you've dealt with a lot of things in Excel. And I think it's something, just for our audience, it's something that you can use in a lot of cases. Like, for instance, when a date is a text in a text format, you could actually format it as a date, and then use text to columns to actually convert it to a date, and it would actually convert to a date. Or like you did if it's an equation or something that is in text, and you want it to be a general or a number, you could format it as such. Before, in this case, it would have been formatted as general. So then Excel deals with it as general. It's the same as pressing F2 and pressing enter repetitively. So that's what text to columns does, which is a very cool trick that only someone with lots of Excel experience would actually know, because they've had to solve that issue in the past. So yeah, it also works for converting numbers stored as text into numbers. But later on, Excel brought the little green tag to say, this looks like a number. Do you want it formatted as a number? And that also gives you the ability to convert numbers without using the text to columns trick. But yeah, what I did was I actually have a little nice VBA piece of code that gives you what do you call it?
You want to share your screen?
Yeah, sure. Let me do it. It's very, very simple. Basically, it's just a function called eval. It takes a reference as a string, so it can take any string reference, and then basically it just evaluates the reference. So the VBA function that doesn't exist in Excel is evaluate, and this gives you the ability to actually use the function eval in Excel itself. So if I have a number in this case, let me just show you. So if I take level 3, for instance, wrong example, that one. So level 3 in this case for me, what I did was I extracted the first number, I extracted the actual block symbol, what the operation is, and then did the same logic that I applied to level 2. I could copy that across and actually use the operation. But with that, I could actually do I could rebuild what the function should be like that by doing equals the first number and then the operation and then the second number. And then for this, I used just my eval function. And the eval function is now available to actually do the calculation of that. It would also exist, I believe, in the name manager. No, it doesn't. Okay, but it's essentially called a what is it called? A user-defined function, a UDF.
Yeah.
So essentially, I could use that as a function now, and I didn't have to do the text to columns, which meant that I could actually put it in a data table. And I think for this, I just sort of built the data table function. With that, I did the search, very similar to what you did in that other example, Steyn. Basically said if it's a number, return it. Search and filter for where it actually is found, and then return for me the human symbol essentially. And then the number, I basically did a text before that operation. And for number 2, I did a text after that operation to extract. So it didn't matter how many numbers there were before and after. I could then eloquently or elegantly extract number 1 and 2, and then convert that. Look, your method is a lot simpler, Steyn, but I want to almost say for my normal brain, this logically makes a lot of sense. So I just wanted to share that, I guess.
Yeah, I mean, just from my side, before we move on to level 4, the stuff that Steyn's done on the screen there is deceivingly complex, right? It's making it look incredibly straightforward. And I think the text to columns trick is a great takeaway as well. I think, if you, like Renier said, if you've spent enough time in Excel, you know the text to columns trick to convert a number that's formatted as text into a number. And that's a phenomenal trick to know. But it's not immediately obvious that having text that says 10 plus 5 in text it's not immediately obvious that converting that into an actual mathematical operation that Excel can evaluate is actually incredibly difficult to do. To evaluate text that's written like a formula is actually really difficult. And the evaluate function that Renier put up, in the user-defined function, I followed a similar approach after Googling how to figure it out. And I did I didn't do a VBA UDF. I set it up in the name manager, and just basically what I found online. You can set it up in the name manager, and call it. You give it a name similar. You called it eval or whatever, and actually, if you wrap the evaluate function inside a lambda in the name manager, it allows you to use the evaluate function, because the evaluate function is what's the right term? XL4 macro function or something like that. I forget what the right terminology is, but it's not available in the base on the grid formula sort of set of formulas you can use, but it is in VBA, and you can coerce it into being used through a lambda in the name manager. Same approach. But that text to columns thing is genius, because Excel, when you do a text to columns on a single column and you just don't try and delimit things, Excel is going to force itself to try and figure out what you're trying to do, convert the date or convert the number or evaluate the formula, which is such a simple hack to know, but it's an incredibly complex problem if you don't actually know that trick. So I mean, yes, if you're watching this walkthrough, like that 10 seconds that Steyn used to explain level 3, like go and watch that in super slow motion and unpack, because there's so much crammed into that 20 seconds or whatever it was. It's phenomenal. Yeah. Sorry,
Okay.
Steyn. Carry on.
And then you get to level 4, which was the interesting one.
It was a very interesting one.
Yeah. So how I did it is very similar to level 3, where I basically did the text split to split it into its different numbers.
Sorry,
Then
so
I did.
just pause for a second. So level 4 means we're not only doing one operation, there's combinations of operations. And then just for kicks and giggles, we change the order of operations so that you can't just evaluate it like a normal human being. Or you can't rely on Excel with the text to columns. You have to actually figure out where to put the multiplication sign and stuff like that, right?
Yes.
Yeah, so the order of operations is essentially moved around. So maybe just go to the question itself, so that we can just for the people who haven't seen the case necessarily yet. So essentially, we do PEMDAS, which is parentheses, exponents, multiplication, division, addition, subtraction. So that is the order of operations that we use, that we've all learned about when we did maths at school. In this case, the Blokens use division, then subtraction, then addition, then multiplication. And then basically the rest of it is the same as previous. So go for it, Steyn.
Okay. Yeah, so I did very similar to level 3, where I do the text split, and then I do the VLOOKUP, which brings it back in human numbers, and then I do a text join to bring it back as an equation. But now I need to change the order, and that was the tricky part. So how I did it is I took this equation here, and then I added the open bracket at the start and a closing bracket at the end. And then I did a substitute on the multiplication to replace it with a closing bracket, opening bracket, or closing bracket, multiplication, opening bracket, which made then each case where there's a multiplication, it basically puts everything else in a bracket. And then
and it makes sense, because essentially the only thing that has changed is the position of the multiplication. And that was the other trick that a lot of people didn't realize, is you just had to deal with multiplication in that case. The rest of it would have been dealt with in the right operation either way.
Yes. And then it was just a matter of copying the formula again, pasting it, and then applying the text to column, which then forced it to evaluate the answer.
I can't believe that answer stayed. I literally spent 2 hours on level 4 and I have not solved it yet. It's like crazy.
So can I share what I did on level 4?
Okay.
Very similar, but there's just one thing that I wanted to show. Let me just share my screen. Okay, so level 4 I did as a data table again. And essentially I initially started doing it like Jason wanted to do it, where initially I went and I split out the numbers by actually using the Blorkin symbols, and that could actually split them out, and I used the trim function to remove any spaces. With that, then I could also get, well, I created, and I'll show my lambda now, but I created a little lambda that's called Blorkin that could now actually convert decimals, or convert Blorkins to decimals, regardless of whether it's positive or negative. And then for operations, I essentially just used an XLOOKUP back from. Okay, so I did the reverse of what I did earlier, where I basically text split that text at the top with my numbers, or using my numbers as row delimiters,
Mm.
which would actually just bring back my Blorkin symbols in the right order, and then just did an XLOOKUP back from Blorkin to human, and that could give me, in the right order, it could give me the different Blorkin symbols. And then I tried to actually determine the order based on the order column that I added over here. And then I tried to do all kinds of things to evaluate them in order, using the sort by function to sort it by the order. I did all kinds of things and I almost got there, but then I realized that the multiplication order is the only one that I had to deal with, and essentially did very much, well, exactly the same as Steyn did, where I rebuilt the function, replacing multiplication with bracket, multiplication bracket, or closing bracket, multiplication opening bracket, and I added an equals opening bracket and equals closing, or just a closing bracket at the end. And then I used my eval function as I did in level 4 or level 3, and put that into a data table. As I've shown you previously, I built out this sort of logic in level 2 already, and using that logic, it was actually pretty quick and simple. Maybe I wouldn't have done it in half an hour, or in half an hour's case, but I basically built the little Blorkin function, firstly with a let, and then converted the let into a lambda. And basically all it's doing, and I'm making it sound simple again, but basically all I'm doing is okay, let me just show it over here. But essentially I'm just taking, I'm just firstly determining if it's a number, and I'm determining if it's a number by saying, well, it is, this is just, so firstly I'm determining, is it a number, and basically I'm just saying, then if that's left of that, in other words, then it is a number. Is it negative? Test for negative. Then I extract the numbers with the logic that I did in level 3, where if it's negative, I pad it afterwards. If it's positive, I pad it before, using the left and the right logic that we spoke of earlier. And then I basically just extracted Blorkin thousands, Blorkin tens, and Blorkin ones based on the logic of level 3, converted that into decimal thousands, tens, and ones using the same logic as I did previously, and then just brought that out, and that could now do Blorkin conversions in bulk, and then, yeah, like I said, use the same logic as Steyn with the same eval function. Steyn, you want to take us through bonus 3 and 4 maybe?
Okay. Okay, so bonus 3 says what's the human equivalent of the largest blocker number we can represent with 4 digits. So I could either use my list that I did here, or if you want to use the different method, then the blocker number 9 is equivalent to number 6 in the base 7. So I did a substitute here, and then that's just the highest number here. And then so it's 6 times 1, 6 times 7, 6 times 49, which is 7 to the power of 2, 6 times 343, which is 7 to the times 3. And if I do a sum product on that, then I can see the human number of that is 2,400, which is also the same that I got here. So 2,400 is the largest blocker number I have here. So that's how I got the 2,400 as the answer. Did you guys do the same? Or
Yeah, yeah, I did it very much in the same way. I used one equation where I basically just did very much like you did. I said 6 times 7 to the power of 0, 6 times 7 to the power of 1, 6 times 7 to the power of 2, and 6 times 7 to the power of 3 all summed together. So in the end, didn't do a sum product and stuff. It was one long equation, but yeah, did it in the same way. And as you said, if you build out the sequence of numbers with 4 digits, the 9999 in Blocken is your 2400th number if you take it in human sequence. So yeah, very interesting question. And again, if you're a math genius, very simple to figure out. And I think we had 1 or 2 people in the finals who actually figured it out in the time or in time, which is very impressive by my standards. I didn't figure it out that quickly, but yeah, very, very cool question.
yes, and then bonus D is basically just the highest number in that question. So it's just taking the max of the answers for level 4, which then gave you that.
Cool.
Hey, Jason, do you want to take?
Similar to bonus B there, the bonus B and bonus D were almost free marks to almost reward you for solving level 2 and level 4. And that's it's a nice sort of strategy to think about in the context of it. We talk about sort of on the day exam technique and things like that. And if you have the awareness and the exam technique to have an understanding of what the questions are asking, bonus B and bonus D were lightning points to get once you'd solved level 2 and level 1 and level 4, level 2 and level 4. Yeah. Just while I'm pulling up level 5, I just want to, just a takeaway for me for the Excel esports stuff, generally speaking, is I think the distinction between Steyn and Renier, how you guys are solving levels 3 and 4, is a good example that to do well in this competition is not necessarily building out the most complicated formula. It's about having the best structure and the best logic and being like super intelligent at problem solving. Because the way that Steyn's doing his like speed run, obviously he understands the case and he knows what to do, but putting up that lookup table, building out the human numbers, blocker numbers, negatives, whatever, and then just doing lookups from an Excel perspective is really not complicated to do. But like, don't underestimate the complexity in coming up with that logic. And I think it's a good takeaway. Like, if you spend time to digest a problem and grapple with how to come up with the most simple solution that works, you can make the actual calculation model incredibly lightweight, actually. Don't just rush in and build a 30-line let function because it works, you know. Yeah, just a, I don't know, we always say when we build models, they need to be as simple as possible, but as complex as necessary. And Steyn's showing there that you can get really simple to get the answer. Anyway, I'm digressing, but good couple of great takeaways for me on this case. Geez.
Yeah, so sorry, I wanted to just add one of my favorite quotes, and I'm going to potentially mess it up now, but it's something like simplifying, or simplification is adding the obvious and removing the unnecessary, or something like that. I'll find the quote, but that to me has stuck to me, and I think the same applies to when you need to do anything, digitalization of processes, automation of processes. In business, it's one of the most worthwhile skills to actually have, and that's to simplify a very difficult problem and solve it like that. Simplicity is about subtracting the obvious and adding the meaningful. That's the quote. So that's what Steyn is doing.
Yeah, similar veins. When we present the modeling training, one of the quotes we put up is, I think it's a well-known sort of more like a written quote, like in terms of language and writing and reports and stuff like that. But saying, I didn't have time to write you a short letter, so I wrote you a long one instead. And the point is that it takes time to simplify and condense and be concise and whatever. But if you can invest that time, especially when you're building up a big model or something like that, and you can make the file efficient because you've really thought about the logic, you can make it far more powerful. Anyway, let's wrap up on level 5. I feel like I've been handed a gift here because level 5 should be the most difficult case, and I should be the one now presenting my Excel prowess. But if you ask me, level 5 should probably have been level 2 in this case. And we in fact said to the participants on the day that we gave them a bit of a heads up that the levels are not necessarily in order of difficulty, and if you get stuck, move on. And
I think level 4 was actually considered very hard. If you see C1 and 4, it says hard for level 5. So yeah, level 5 is considered hard, but level 4 is very hard.
Yeah.
And it's really like that. And a lot of people actually went on to level 5 and solved it, but didn't solve level 4.
Yeah. So actually, I think once you'd solved level 1 and you had the logic of how to sum up the numbers and things like that, level 5 was actually relatively straightforward to do, and just required you to turn your smiley face into a frowny face. I looked that up while we were talking. It's called an upper half circle and a lower half circle, just as a takeaway. Now we know, but we'll go with smiley face and frowny face. Level 5, I did sort of a more traditional pull in the example, pull in the content, and then run a data table. But to be honest, a lot of the logic that I've done here, we've spoken about in quite a lot of detail already. So this was actually relatively simple once you understood the logic. So I've pulled in the string of text from example 5. I've pulled in this upper half circle, my frowny face. I've done a text split on that delimiter, and I've trimmed it because there were some spaces in the string which I didn't need, so the trim just dropped that. You'll see that I built this out offset by 1 row just because my first delimiter gave me a blank and I didn't feel like dealing with that in a more neat way. I just started 1 row down. And then, to be honest, much the same as what we've spoken about, so I won't dwell on this much. Pull the length, split out the values, hundreds, tens, units, to the power, value times 7 to the power of 2, to the power of 1, to the power of 0, sum them up. And then you had your values that you had to look up. I gave myself a little bit of extra room because some of the sentences were, 1 or 2 words longer. Interestingly enough, on the day, some of our top competitors, I think, focused on example 5 and took it to be 5 words in the sentence, and didn't realize that some sentences had 6 or 7 words. I can't remember if they got to 7, but certainly 6 in some cases, and actually missed out on points because they just didn't give themselves space. And that was a bit of a curveball. But anyway, built out some space for myself. And then before moving from number to word in Blorken, we had to deal with the word list. So we were given a list.
Sorry, Jason. I just wanted to add. I think that missing out on 5 versus 6 words in the sentence, I think that could have cost a participant 5,000 rand. In that case, I think it was one of the deciding factors between second and third, or third and fourth, or something like that.
Yeah, it was.
So it potentially cost one of the participants 5 grand. So just expensive mistake.
Absolutely, yeah. I think 3 and 4 were separated by 3 points or something like that, right? Anyway, yeah. So it was literally lucky guess on one question, or not picking up that this was 6 words. Anyway, so we were given a word list, which is basically just a corresponding number in human numbers, and then a word. And the reason I know it's human numbers because I see a 4 and a 5 here. I didn't go back and check. But all that I did basically is just V-stack these ranges into one lookup table. I don't know if there was a cooler way to do that, but I just stacked them into one big column.
There was a cooler way to do it. You could have used a wrap. Let me just see, wrap rows.
Wrap rows.
You could have done a 2 call and a wrap rows if you wanted to. Then you could have wrapped it back.
How do I wrap rows with wrap count 2?
Wrap count 2, yes. Wrap rows, wrap count 2, and a 2 call ignoring blanks. You could have selected the whole block with the 2 call and then wrapped it back into rows.
I see. Everything in a 2 call. Oh yeah. Put everything in one column and then wrap them 2. Okay. Yeah. Good call. Okay. Happy. V-stack fairly manually, but pretty quick. It wasn't a long table, so it worked. And then just for the haters out there, I did a VLOOKUP on the number, and funny enough, the reason VLOOKUP is quick here is because you only have to reference the table once. You don't have to reference the 2 columns separately. So if you've got a 2 column table, VLOOKUP actually is quicker to write, I think. But I just named this list words, boom, words, and then so VLOOKUP, that number in words, comma 2, false. I forgot the first time to put the false in again. Thank goodness XLOOKUP doesn't require that nonsense. And then I put an if error so that I could deal with my spaces to give me the blanks here. And then really just a text join with spaces to make it a sentence. The true function really useful in the text join to ignore the error, to ignore the blanks or the empties. And then this was just a data table that ran through questions 81 to 100. And that gave me level 5 far more quickly than even level 2, I think, for me. Maybe anything to add there from any of you guys before I move on to bonus E?
No, I did it in a very similar vein. I was just thinking about that first character, or the first thing, how to deal with that. You could have used the drop or the take function for that. You could have dropped the first one or taken everything except for the first one. I also did the text join very similar to you. So I also saw that bonus 5 you did in a separate block, but I did mine as part of the same data table. But I'm sure you'll get to bonus 5 now. You did it on that side. Yeah.
I just did it. Yeah. Because bonus 5, you actually didn't need to
Yeah,
solve the words, really. You didn't have
exactly.
to. And so bonus 5, you could actually have just have done without. So bonus 5, different to bonus E, I should say, different to bonus B and bonus D. You didn't actually have to do anything on level 5. You just needed to understand the logic of what was being presented to you. But essentially, a text split of the values for that upper half circle, frowny face. And that split out the values, subtract 1 because of that first gap, I think, and then just count the number of cells. So that was the number of words that were being given. And then the question, bonus E, was how many words are there in the level 5? And so basically just sum them up.
Very, very interesting. You could have just counted this frowny face. So I see that you did the text split and that counted everything that wasn't split, but you could have just counted the occurrence of the frowny face.
Find how many frowny faces there were.
Yeah.
Yeah.
And you're very, very easy 70 points there.
Yeah, absolutely. Most points for the bonus, but actually didn't have to solve the level. Not a complicated setup. Could so I think if you had your wits about you in this case, you could have scored some of the higher points pretty easily, where people were sort of floundering around, getting stuck on level 2 and 3 and 4, or not solving.
And there were actually zeros in this case, right? So people were so flustered by the logic of this case that we actually had zeros.
Yeah.
And I mean, hopefully they're watching this video, especially the ones who got 0. And hopefully you are like, oh, you know what? I need to learn how to not be flustered and realize where there's easy points and just apply some logic, because you realize that it's actually not that bad once you start unpacking it, and if you just calm down and smell the roses and then take a breath and then start solving the case. Yeah. But yeah, thanks, Steyn. I think one of the coolest cases that we've had up to this point. Very interesting. I loved it. It was everything a finals case should be. And like I said, I think I really want to see the international competitors, how they do, the Gene Vollers and the Dim and Julian and Lorenzo Forti. I think there's a lot of very good competitors on the international scene that's also going to attempt the case tomorrow, and they'll be sharing it on their YouTube channel. So go follow them as well. Each of them have a very unique way of presenting how they do it, and they're all amazing. I wish that I could, when I grow up, I would want to be a case solver like they are. But I guess I need to spend a lot more time on building lambdas and practicing. But yeah, I'm looking forward to how they attempt it and how they solve it, especially Adam, because he's also a complete mathematical computer genius. So he's probably going to also find interesting ways to do it. And the best thing is, what takes us a day or two to brew on takes him 10 or 15 minutes, and then he's like solved it. So yeah. Any closing thoughts from you guys?
Yes. One thing that was interestingly difficult was getting a picture with 3 fingers, because it kept generating ones with 4 fingers.
Yeah. So yeah, Steyn was actually talking about the picture for the case, because we used AI to create the pictures of all the cases, and that's what we used to actually share on social media with. And I think it took me 12 iterations trying to wrestle with ChatGPT. Oh, sorry, I think I actually used Copilot in this case. So I was speaking to Copilot and I was like, Copilot, can I please get an alien with 3 fingers on each hand and a tail? And it came back with 4 fingers every single time. And then I said, no, 3 fingers per hand. Came back with 4. I said, okay, remove 1 finger from the right hand, and it removed a finger from the left hand. And I was like, okay, remove a finger from the hand on the left, and it came back with 2 fingers. And I was like, no, I'd removed 2 fingers. And I'm like, okay, put back 1 finger. And then it put back 2 fingers. Oh, it was so painful. So AI is not there yet, but I'm sure if we watch this video in 6 months' time, we'll be telling a different story. But there's still a lot of things that AI can't do. So very happy about that, though.
Yeah. Just thanks again to, I guess, the team for a good season, and looking forward to next year. And well done to Michael for taking the top honors again. Yeah, it's great. It was a great season again.
Yeah, thanks. We're very fortunate to have very good competitors. Michael is busy sorting out his visa application to travel to Vegas. He's actually flying to Durban because that's the only place where he could get a visa appointment in time, which is crazy if you think about it. You can only get a visa appointment in December at this stage in Cape Town and in Joburg. So yeah, he's flying to Durban to go attend his visa appointment. So yeah, we're working hard to get him to Vegas. But yeah, looking forward to seeing him compete as well. Hopefully, he's building out his lambdas. And we're hoping for a good result. Otherwise, just seeing a South African up there and seeing him represent is enough for us. So yeah, thanks to all the guys who participated in the 2025 season for the Microsoft Excel World Championship South Africa. Again, very impressed by the caliber and the quality that we're producing in South Africa. If I compare that with 3 years ago, we've grown exponentially in numbers and in skills. Very proud of what our South African contingent is doing across the country, even in the collegiate challenge with Peter Pienaar, what Peter is doing with the university students as well. We're seeing a lot more of university students. So very exciting and amazing to see problem solving and Excel skills grow in this country. Thank you, gentlemen. Have a lovely evening, and I guess we'll chat again in a couple of months' time. But Jason, did you say you're going to start your next case for next week, right?
I said I was going to do it on the evening of the finals, which hasn't materialized, unsurprisingly. But I do need to do it sometime this side of December, so that it's done not on the morning of the finals.
Yeah, but that's how the best cases come about, right? Is when you do it under time pressure, and that's when you do your best work. But yeah, okay, guys, thank you, and we'll chat soon. Bye.
Yeah, good night.
Thanks, bye.